ever feel like we're just drowning in data these days? I mean, everywhere you look, it's just exploding.
Yeah.
And it makes you wonder, like, how do computers even deal with storing all of that information? Well, that's exactly what we're diving into today. Distributed file systems.
It's a fascinating area.
Yeah. And these systems are quietly powering so much of our digital lives. So get ready for some, hopefully, pretty interesting facts.
Yeah, what's really cool about distributed file systems is that they're built to make these huge, massive amounts of data easily accessible, even when it's spread out across tons of computers.
So it's kind of like, imagine if you had a library, but instead of all the books being in one place, they were spread out across different floors or even different buildings.
Right.
But you could still find any book you wanted seamlessly.
Exactly.
Yeah,
That's the magic of a really well-designed distributed file system.
that's a great analogy. So how did we even get here? These systems must have had some kind of starting point, right? It's not like they just magically appeared one day.
Definitely not. It all really started with, just the basic need to share files between computers on a network, like way back in the 1980s.
Oh, wow. So we're going way back.
Yeah, researchers were trying to basically link up separate UNIX systems. It was kind of
Yeah.
like the very, very beginning of computer networks.
Yeah, okay.
And one of the earliest distributed file systems actually came out of this effort.
It was
It
called
was called UNIX United.
UNX United. Sounds very official. What was so groundbreaking about it?
Well, they stumbled upon this really important idea, this concept of transparency.
Sorry, the parents. Okay.
They wanted to make it so that you could access a file on a remote computer,
Right.
but it felt exactly the same as if you were accessing a file on your own computer.
Gotcha.
So a seamless experience. And back then that was revolutionary.
Yeah, I bet. So no more like digging through complicated network folders trying to figure out where things are.
Exactly. Ideally not at all. You want to hide all of that. The goal is to abstract away all of the complexity of this, distributed system. The user shouldn't even know.
That makes sense, so it just works.
Right.
I'm guessing these early systems were pretty bare bones, though.
Oh, yeah, for sure. Yeah, at the beginning, the focus was mostly on just simple file sharing. But then computer scientists were like, wait a minute, what if we could make these file systems not just distributed, but actually smart?
Okay, now we're talking.
Right.
It's not just about storing files anymore.
Exactly.
It's about how to manage them really effectively across the entire network.
Yeah, and that's where these concepts like file mobility and location independence came in.
Okay.
Like game changer. So imagine a file could intelligently move itself to a server that has more power or that's physically closer to the user who needs to access it.
Wow.
And all of this is happening behind the scenes. You don't have to wait for files to transfer or try to remember, oh, which server was that file on again?
Right.
It just happens.
That's wild. That
Yeah.
sounds incredibly efficient.
Yeah.
But I can only imagine that all this new complexity
Yeah.
probably comes with a whole new set of challenges too, right?
Oh, for sure. Big time. One of the biggest hurdles is just maintaining that transparency we were talking about.
Right.
You want to keep users shielded from all those messy details of how distributed storage actually works.
Right, because most people, they don't care.
Exactly. Think of it like this. You go to a restaurant, you're enjoying a delicious meal. You don't want to see what's going on in the kitchen right
No,
now.
I just want my food.
Exactly.
I just want my data. And I want it to appear when I click on it. That's all I care about.
Exactly. Yeah.
So transparency is one.
Yeah.
What are some of the other big challenges?
So another big one is this idea of fault tolerance.
Yeah, tolerance.
Like, if you're storing data across multiple machines, what happens if one of those machines just crashes?
Oh, right.
It happens. So a good distributed file system needs built-in redundancy, kind of like having backup generators, or a spare tire for your car.
Backup plans.
Exactly. You got to be prepared so that the system can handle these failures gracefully and you don't lose any data.
So it's kind of like having a safety net for your data,
Right.
making sure that it's always protected no matter what happens.
Yeah.
Okay,
Yeah.
that makes sense. But we're talking about challenges. So fault tolerance is a big one. What else is there?
Ah, right. So there's also scalability, which is huge. Imagine a library again. This library has to keep up with a constantly growing collection of books.
Okay, yeah.
So a scalable distributed file system, it's like this magical library that just expands effortlessly as you add more and more data.
It just adapts.
Yeah, no problem.
Wow. So I've got transparency, fault tolerance, scalability. Those are some pretty big hurdles to overcome.
Yeah.
But obviously, they're working because these systems are everywhere. And I know we touched on how important they are for things like, Google searches and all of that. But what are some other like real-world applications? Where else do we see these distributed file systems popping up?
Oh my gosh, they're practically everywhere. I mean, if you think about like large-scale data processing,
Okay.
so when you've got these massive, massive data sets, you need a really, really robust system to handle it. So like Facebook, for example, all the information they collect.
Right. It's got to be a lot.
Oh, tons. It's like having this team of super organized librarians who can like instantly find any piece of information you want, but within this like mountain of
Yeah,
books.
they have the Dewey Decimal System memorized
Yeah.
backwards and forwards. Okay, that's incredible. But it's not just about storing data, right? It's also about understanding it, making sense of it.
Oh, absolutely, yeah. And this is where distributed file systems become really essential for things like parallel computing,
Parallel computing, okay.
where you've got multiple computers all working together on a shared task. It's kind of like imagine you're trying to solve a giant jigsaw puzzle.
Okay, yeah.
By yourself, it would take forever, right?
Well,
But if you could like divide up that puzzle into sections and have a team working on it, simultaneously, it would go so much faster.
right.
That's kind of what parallel computing is like. And distributed file systems are really the key to making that happen.
Gotcha. So they're like master collaborators.
Yeah.
They let all these computers work together, which actually, this brings up a question I've been wondering about.
Okay.
How are distributed file systems different from databases? Because I know they both kind of deal with data, but there must be some distinction there.
Yeah, that's a great question. It's really easy to get them confused because they sound very similar.
Right. They're both storing stuff.
Right. But they have different purposes. Think of a database like a super meticulously organized library catalog.
Okay.
So it's optimized for like searching and retrieving really specific information very, very quickly. Like, if you want to find a book and you know the title or the author.
So the database is like the index that helps me find what I'm looking for.
Exactly, yeah.
Okay. So then what's the distributed file system in that analogy?
So the distributed file system is like the actual physical library building itself,
Gotcha.
providing the structure to store and manage all of this vast amount of data, but not just text. It
Yeah.
could be images, videos, audio files, all kinds of stuff.
So it's like one's the information and one's the building where the information's kept.
Yeah, kind of, yeah.
Okay. That makes a lot of sense. But let's get into like the nuts and bolts a little bit here, like how these distributed file systems actually work. What are some of the like big innovations that have been made in this field, like the things that have really kind of revolutionized how it all works?
Yeah, for sure. So one really cool example is a system called Sprite.
Right.
Yeah, it uses this really, really clever mechanism called prefix tables
Right.
to keep track of files that are scattered all over the network. So imagine it's like a dynamic address book, but for all your files. And it's
Yeah.
constantly updating itself in real time. So you always know exactly where to find a particular file, no matter where it's located.
It's like a GPS, but for my data. Okay, that's super clever. What else? What other cool innovations have they come up with?
So there's another really groundbreaking system called Andrew.
Andrew.
And it takes this really interesting approach, this volume-based approach to managing user data. So imagine like when you move houses,
Okay, yeah.
you pack your belongings into these boxes, right?
Right.
So Andrew, it uses the similar idea, right? It organizes data into these manageable volumes that can be easily moved around the network and accessed efficiently.
Okay, so it's like these neat little packages of data
Yeah, exactly.
that can be like easily accessed or transferred or whatever you need to
Yeah,
do.
exactly.
Okay, that's a really good way to think about it.
Yeah.
What else? Are there any other innovations that come to
Oh, yeah, tons. We can't forget about Locus.
focus?
It focuses on replication and something called atomic updates, which are crucial for making sure your data isn't all messed up. It's like imagine this perfectly synchronized dance where every single move is coordinated down to the smallest detail.
Okay.
So that's essentially how Locus works. It makes sure that all the copies of your data are updated in a precise and really reliable way.
So if I make a change to a file in a distributed system,
Right.
Locus makes sure that that change shows up everywhere
Exactly.
instantly.
Yes.
Wow. Okay. That's super important.
Yeah, you don't want to have like different versions of files floating around.
Yeah, for sure. Okay, so we've talked about some of these innovations, but I'm guessing even with all these amazing advances, there are still challenges, like limitations to what
Mhm.
these systems can do, right?
Oh, for sure. I mean, creating a system that's both really powerful and incredibly reliable across, an entire network of computers,
Right.
that's not easy at all. So
Yeah.
one of the biggest challenges is just the sheer complexity of it all.
Right.
Building a distributed file system that can handle all these intricate processes without, completely falling apart. It's like
Yeah.
trying to orchestrate a symphony.
A symphony of computers.
Exactly. With all these different instruments playing in perfect harmony.
Right. And too many instruments.
Yeah, it's,
Okay.
yeah.
Yeah. So complexity is a big one. What else? What are some other challenges that they're grappling with?
Another big one is just maintaining consistency
Good.
across all those copies of your data.
Right. Because if it's everywhere.
Yeah. You want to make sure that everyone who's accessing this system, no matter which machine they're on,
Right.
they're seeing the same up-to-date information.
It's like trying to keep everyone on the same page of a Google Doc when like 50 people are editing it at the same time.
Exactly. Yeah.
Hmm.
It's tricky.
Okay. So consistency is another one.
Yeah. And then, of course, there's security.
Oh, right. Always a big one.
Always, yeah. I mean, when you've got potentially sensitive information spread out across an entire network,
Yeah. You got to make sure it's locked down.
you got to make sure that it's protected from people who shouldn't have access to it. It's like having a high-tech security system for your data,
Yeah.
constantly guarding against all these potential threats.
Cybersecurity.
Exactly.
So there's like a constant balancing act.
Yeah,
You've got the complexity, you've got consistency, you've got security, and who knows what else.
right. All of it, all at the same time.
It's amazing that these systems work as well as they do.
I know. It really is. You don't even realize how intricate it all is behind the scenes.
Right. We just take it for granted. Click, 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 and it works. It's pretty amazing when you think about it. All those challenges they have to overcome just to make these systems work. But it's clear they've become, like, essential.
Yeah.
You know?
Totally. I mean, they've completely changed how we store, access, process, you name it.
Yeah, everything.
Yeah.
Everything runs on this stuff now. So where do we go from here? Like, what does the future hold for distributed file systems? Any exciting new developments on the horizon?
Oh, always. One area that's super interesting right now is using things like optical networking
Okay.
and non-volatile RAM to like really push the limits of speed, how fast we can store and access data.
Yeah, you're speaking my language. Faster is always better. Tell me more about those, though. What makes them so revolutionary?
Okay, so picture this. Data flying at the speed of light
Wow.
through these optical networks.
Okay.
The skids we have now would seem like a crawl in comparison.
Yeah, right.
And then on top of that, you have non-volatile RAM. So it's like it can remember data even when the power goes out.
Oh, wow.
So you get the speed of RAM, but it's permanent like a hard drive.
It's like having your cake and eating it, too.
Exactly. A
Yeah.
super fast, always on memory bank.
Okay, it sounds like something out of science fiction. But this is, like, actually happening.
What is? It's becoming reality.
What kind of impact could those technologies have on just, like, everyday life, you think?
Oh, the possibilities are huge. Imagine a world with like almost zero lag time, where you could analyze these massive data sets in the blink of an eye and all our devices just work like so much faster and smoother.
Yeah, that'd be nice.
Right. It could change everything from like scientific research, healthcare, even entertainment, and how we communicate.
It's crazy to think about. It sounds like we're on the verge of this whole new era in computing. And it's all thanks to these, like, advancements in distributed file systems.
Yeah, pretty much.
Before we wrap up, is there one, like, big takeaway you want to leave our listeners with? Like, what's the most important thing to remember about all this?
I'd say it's this. The future of information, it isn't about just cramming more and more data onto bigger hard drives.
Right.
It's about creating these really smart distributed systems that can handle this constant flow of information and make sure it's available whenever, wherever we need it. It's about building this like invisible infrastructure that empowers us to do more, connect, collaborate, just innovate in ways we can barely imagine right now.
That's a great point. Distributed file systems, the unsung heroes of the digital age, they're working behind the scenes, making all this stuff possible. Well, this has been a fascinating look into the world of data storage. Thanks for joining us on this deep dive, and we'll catch you next time as we explore another topic that's shaping our world.